Every time you get a shot or an IV or really any kind of modern medical treatment, you are connected to an ancient secret. There's this unbelievable, unseen guardian in the medical world, a living fossil whose biology is literally keeping us safe. So what on earth is it?
I mean, seriously, what is it that actually keeps our medicine safe? It's one of those things we just take for granted, right? We trust that a vaccine is sterile, but how do we know that for sure? Well, the answer isn't some super high-tech futuristic gadget. Nope. It's actually found in the veins of an ancient creature from the sea.
Yeah, you heard that right. It's wild, isn't it? This isn't some abstract science thing we're talking about. It is a direct personal connection. If you've had a vaccine, an IV, insulin, you are part of this story. Our entire healthcare system is completely intertwined with this one animal. So yeah, this affects pretty much all of us.
So here it is. Meet the horseshoe crab. And a fun fact for you, it's not actually a crab at all. It's more closely related to spiders and scorpions. Kinda creepy, but cool, right? This thing is a survivor. We're talking 450 million years. It has watched mass extinctions come and go. And today, it has this critical hidden job, protecting you. But how? Well, the secret is in its blood. Okay, so let's dive into the science of this blue blood, this prehistoric miracle. How on earth does an animal this ancient protect us in the 21st century? Well, the magic is all in the blood. But to understand the miracle, we first have to understand the invisible enemy it's fighting. The bad guy in this story is something called an endotoxin. You can think of them like these tiny toxic ghosts left behind by dead bacteria. They're everywhere, they're incredibly hard to get rid of, and if they sneak into our medical stuff like injectable drugs or equipment, they can be really, really dangerous. We're talking fever, shock, even death. So being able to find them is, and I mean this, absolutely critical.
And this is where our prehistoric hero comes in. Its blood is, well, it's blue. For real. Our blood is red because of iron, right? Theirs is blue because of copper. And inside this blue blood are these amazing cells called amoebocytes. The best way to think of them is like the crab's personal squad of immune system super soldiers, and they have this crazy, almost supernatural power to detect bacteria. So, how do we use this superpower? Through something called the Lal test, and honestly, it's genius in its simplicity. You take an extract from those super soldier blood cells, and you mix it with whatever you're testing. If there is even a tiny, minuscule trace of an endotoxin in there, bam, the whole mixture instantly clots up and turns into this solid gel. It's like the perfect, lightning-fast alarm system.
Now, to really get why this was such a game changer, you have to look at what we were doing before. The old way was called the rabbit pyrogen test, and yeah, it's pretty much what it sounds like. They would inject samples into live rabbits and then just wait around to see if they got a fever. It was slow, it was expensive, and it used thousands upon thousands of rabbits. So when the LAL test came along, this fast, super sensitive test you could do in a little glass vial, it was a massive leap forward, a huge win for science, and at the time for animal welfare too.
But, as it turns out, that big ethical win wasn't so simple. This miracle blue blood, it comes at a price. And we're only now really starting to understand the true cost for the horseshoe crabs themselves. Just let that number sink in for a second. Over 500,000. That's how many horseshoe crabs were collected for this process in a single year. And that's just in the United States. This is not a small-time thing. We're talking about a massive industrial-scale harvest that the entire global pharmaceutical industry relies on. So here's how it works. The crabs are gathered up from the wild, usually when they come to shore during their mating season. They get taken to a lab where about a third of their blood is drained. And then they're returned to the ocean. Sounds okay, right? They're put back alive. But the stress of that whole ordeal is a key reason why the species is now officially classified as vulnerable. So this leads to the million-dollar question, doesn't it? What is the real cost to these animals? Because just being put back in the water doesn't mean everything's all good. And this, right here, is where the debate among scientists gets really intense.
And here's where things get murky. The official number the industry generally uses is that about 15% of the crabs die from the bleeding process. But some independent studies have found that number could be way higher, like almost 30% higher. That's nearly double. We're talking about tens of thousands of extra deaths that might not even be getting counted.
And it's not just about who lives and who dies. For the crabs that survive, it's still a rough ride. They can be left disoriented, weakened, and their immune systems can be compromised.
Studies have shown they're less active and less likely to successfully mate after they've been bled. And that, of course, has a huge long-term impact on the entire population.
So, all of this growing concern has pushed scientists to find a better way. And here's the kicker. A solution actually exists, but, and this is a big but, getting people to actually use it has started a whole new controversy.
It's called recombinant factor C, or RFC for short. What it is basically is a synthetic version of that magic ingredient in the crab's blood, but it's made in a lab. So instead of harvesting it from the animal, we can just create it. It's done using genetic engineering, so 0 crabs are harmed. And get this, it's not some brand new experimental thing. It's been around for years, since 2003.
So for conservation groups, the fact that RFC even exists changes everything. The whole ethical equation is different now. The debate isn't about whether we can replace the crabs, it's about the fact that we can, but we aren't. As this quote says, it just completely changes the conversation.
But then you have the other side. For the pharmaceutical industry, the #1 priority above all else is patient safety. And this quote captures their caution perfectly. They're saying, look, the LAL test from crabs has worked for decades. We know it's reliable. Switching to a new method is a huge decision, and for them, there just isn't enough data yet to prove the synthetic version is 100% just as good in every single situation. They're sure it's probably fine, but probably isn't good enough in their world.
And that leaves us right here, at a crossroads. We're stuck in this incredibly difficult balancing act between conservation, regulation, and the deep-seated caution of an industry where a mistake can be fatal.
And a huge part of this problem is this regulatory divide. It's wild. In Europe, the regulators have said, yep, the synthetic test is an equal alternative, you can use it. But in the United States, the regulators hit the brakes. They actually canceled a proposal to give it equal status. So when you have this kind of major disagreement between global powers, it makes it incredibly difficult for big international drug companies to make the switch.
So the future for both the horseshoe crab and for how we test our medicines is just stuck in this complex web. You've got conservationists pushing hard for change, regulators all over the world moving at different speeds, and corporations carefully weighing the massive risks of changing a standard that has kept patients safe for decades.
And ultimately, it really does boil down to this one incredibly tough question. The LAL test from crabs was itself a huge ethical step up from using rabbits. Now we face a new dilemma. We have a technology that could spare this ancient creature, but it requires a leap of faith from an industry that is built on absolute certainty. And there's just no easy answer to that.